discussed about the isomer of coordination compound. Geometrical isomer, we have discussed the types of cis-trans isomer. For the square, planar, and octahedral complex, we have discussed in details. Today we will discuss about the optical isomer of the coordinate complexes. Coordination compounds. As we have discussed in previous class, the optical isomerism is only possible when the mirror image of the compound is not superposable with the real one.
Sir,
Like, yes, please.
sir, yesterday you were given some questions. I have problem in question 9.6.
9.6.
Yes,
NiCl4 minus is paramagnetic when NiCl4 is diamagnetic, though both are tetrahedral. Okay.
yes, sir. NiCl4 में problem था.
Okay. So NiCl4
is a weak ligand and CO is a strong ligand.
Strong field ligand Q. This is.
And
yes.
so pushes the two the paramagnetic electrons back to the 8th shell to complete the octet of nickel.
Strong
Okay.
field and weak theory.
Yes. Though both is tetrahedral. Okay.
Yes, sir. Okay.
Is it clear? Now answer is clear.
Yes, sir.
Okay. Okay, so now we can start the discussion. Optical isomer, that we have already explained that the optical isomerization is only possible if the mirror image is not superimposable with the original one. Like the letter B, as we have already explained, if we take the mirror image of letter B on the plane, then it is not superimposable with the original one. However, letter H, the mirror image is imposable with the H. Okay, so B is giving the optical isomer, but A is not. Optical isomer means it is rotating the plane polarized light. Plane polarized light. Light is a wave, so having a particular direction. And plane polarized light means we are taking single light in a single plane. The sine wave in one plane. This light we are taking. When we are taking this light and it is going through the optically active compound, then it is rotating the light to a particular direction. Means the plane is changed. And from here we can measure whether it is optical isomer or not. Anyway, this is the other topic that will little bit discussed during the discussion of organic isomerism. Here is also the same thing to measure the optical isomerism of the coordination compound. And if the mirror image and the actual compound is two different compounds, mirror image is not superimposable, so mirror image itself a compound and the other one is the another compound. These two, which is the mirror image but not superimposable, that is the enantiomer. And the molecule which is not superimposable, we can call them a chiral molecule, optically active or chiral molecule. Actually, chiral term is used for the organic chemistry chiral center. We can also say the optically active compound. And among those two enantiomer, one of the enantiomer rotate the plane polarized light to the right and other will rotate it left, but the value must be same. Only the rotation pattern is different. Say one is rotating to the, like the clock is rotating right hand side, and other is rotating on the left hand side when value is same. Okay, only the side is different or sign is different. We can put dextro, which is rotating towards right, and levo or DL, small d, small l, or capital D, capital L, you can use for dextro or right side rotation, and levo for left side rotation. Okay, and optical isomer is common in octahedral complex with bidentate ligands. If in octahedral complex bidentate ligand is present, then it is showing the optical isomerism. Okay, here also cis trans isomerism is possible. It will give the geometrical isomer. But only cis isomer shows the optical activity, not the trans one. Square planar complexes are generally optically inactive in case of square planar complex because the molecular plane itself a plane of symmetry. Plane of symmetry means here we must have to understand, we'll read this plane of symmetry, center of symmetry in your organic portion or covalent bonding. Here let us give you the preliminary idea about the plane of symmetry. Plane of symmetry means a imaginary plane within the molecule, not outside the molecule. The imaginary plane within the molecule, so that one half of the molecule is just the mirror image of other half. Am I clear? Within a molecule, you may place a imaginary plane so that one half of the molecule is just the mirror image of other half. This is called the plane of symmetry. In case of the square planar complexes, it is planar. So the plane itself, we can pass a plane by intercepting the molecule. The plane itself is the plane of symmetry for square planar complex. Okay. But in case of octahedral complex, in cis isomer, in case of trans, this plane of symmetry exists. If we see the trans isomer in case of this type of PTCl2En2 compound. This is the tetrahedral complex. In the case of tetrahedral complex, cis isomer, tetrahedral A2 PB type compound. So we can consider here, no, this is octahedral complex. A, yes, A2 B, sorry, PB. Hello.
फिर से सर का नेट चला गया क्या?
Due to activity in the ligand, optical activity in the ligand. Here pH in downside and Me up and down. So in this molecule, no plane of symmetry exists. If we pass a plane through this, it is not having plane of symmetry because pH and H is not the mirror image of each other. Even it is not possible to have the plane of symmetry through this or through this. So molecule is optically active. So if such type of ligand is present with the square planar complex, then square planar complex may show optical activity. So square planar complex itself is not optical activity, only depending on the ligand present. If ligand itself is optically active, then it may show optical activity. In case of octahedral complex, Ma2B2C2 and Ma2B2CD, Ma2BCDE and MABCDEF, those may show the optical activity. Okay, now Ma2B2C2 have 5 geometrical isomer, of which only one gives the optical isomerism. Ma2B2C2. Here is the structure. These are having 5 geometrical isomers. However, only one is optically active. This is the structure. In case of Ma3, the optical activity shows this form, cis form. And in case of Ma2B2, the cis form also shows optical activity. Is it clear?
Yes, sir.
So, to explain whether the molecule is optically active or not, you should look on the molecule to find the presence of plane of planarity. If there is no plane of planarity, then plane of symmetry, then the molecule is optically active. Okay. Next, up to this we have explained the structure, geometrical isomer and the optical isomer of the coordination compound. Here is other type of isomerization is possible, like coordination isomerism. Coordination isomerism means this is a coordination complex of 2 complex, and just exchange of ligand will give the coordination isomerism, like CONH3 whole 6, CrCN whole 6. So this is the positive part and this is the negative part. Now when the ligand is exchanged, that is Cr is having NH3 and CO is having CN. In that case, these two having the same molecular formula but different properties, structure. So we are calling them as a coordination isomer. Ligand exchange between the metal ions present in the coordination compound. Is it clear? In case of ionization isomer, sorry.
Sir, can you repeat coordinate isomer?
In case of coordination isomer, the positive and negative part both is coordination complex. And here the metal ion is having the different ligands. With CO, here NH3 ligand is present. With this, with chromium, the NH3 ligand is present. So ligand position is exchanged here. or metal is exchanged, its position. And that is why those both are having same chemical formula but different properties. Okay, this will give here the positive ion, and COCN6 minus will give negative ion in the aqueous solution. Here CONH3 will give the positive ion, CrCN6 will give the negative ion. Is it clear? Ligand exchange its position to give the coordination isomer. Ionization isomer means we are getting different ion during the ionization or during the in the aqueous solution of the coordination complex. Means the ions are just exchange their position. One ion from the primary valency goes to secondary valency, like CONH3 whole 5 SO4 Br. Here 5NH3, when we are ionizing, we are getting 1 Br minus and this as a plus. But if we consider this is CONH3 5 Br and SO4 2 minus is outside. So when we are making the solution of this, we are getting this as a plus and SO4 as a minus. So we are getting different ions during the making of aqueous solution or in solution state. Counter ion is different. Is it clear? This is the ionization isomerism. Here also you can see CO is, charge on CO is different. Okay?
Yes, sir.
Hydrate or solvate isomerism. Hydrate or solvate isomerism means the during the position of water molecule in the compound is different. It is either satisfying the secondary valency or it is present as a crystal water. Okay, like CrH2O whole 6 Cl3. In that case 3Cl minus we are getting, but when we are 1 Cl is included, one water is present as a crystal water. So this is position of water is different. This is the hydrate or solvate isomerism. And linkage isomerism means it is in case of ambidentate ligand. Ambidentate ligand, we have already defined what is ambidentate ligand. In case of ambidentate ligand, this type of isomerization is possible. Like it may form the thiocyanate ligand, it may give NHCS minus or it may present as MNCS or MSCN. Through S or N, the bonding is possible. This is known as linkage isomerism. Or in case of NO2, it may share the ONO or NO2, means electron may share through N or O. This linkage isomerization is possible for the ambidentate ligand case. Okay, so for this you have to know the definition and you have to know the example 1 or 2 example. Okay, here the special case of AB2 or AO B2O3 bioxides metal bioxides. When AB metal is A is 2 plus and B is 3 plus. So in those cases, they may present as a spinel structure. Those are not having the regular packing structure like FCC crystal or BCC crystal. Rather than they may present in spinel structure. Spinel is type of FCC packing of anions, but position of cation is different and it is included both the tetrahedral and octahedral geometry. Okay, like partial occupancy of both tetrahedral and octahedral site. 1/8 of the tetrahedral site and half of the octahedral site are occupied by the metal ions. And a spinel unit cell is made up of 8 FCC cells by oxygen in configuration. Okay, 8. This is very difficult to find a unit cell. Unit cell we are considering 8 FCC cell. This is a big giant cell made up of oxygen ions in configuration. So in unit cell, 32 oxygen atom is present and 8A atom, 16B atom, 8A 2 plus and 16B 3 plus is present. This is the special structure for this type of bioxides, AB2O4 or AOB2O3. Okay, and depending on the how cation occupied different interstices, spinel structure can be normal or inverse. So two types of spinel structure possible. Either it may be normal or it may be inverse, depending on the how cation occupy. So tetrahedral or octahedral sites are available for within the spinel, and which one is occupying the tetrahedral and which one is occupying the octahedral, that we have to consider to get the spinel structure. Okay. So in case of normal spinel, so two types of spinel we are considering. One is normal and one is inverse spinel. In case of normal spinel, it is having the formula, same formula, A2 plus B3 plus O4. Formula is same. Example of having normal spinel is MgAl2O4, FeAl2O4, COAl2O4, ZnF2O4, etc. Okay, cadmium F2O4. Remember that here Mg, Fe, Co, Zn and Cd are in 2 plus and Al, Fe, in case of zinc or cadmium, Fe is 3 plus. Okay, here in case of normal spinel, it is the thumb rule for normal spinel that A2 plus ion occupy the tetrahedral site and B3 plus ion occupy the octahedral site. This is from the normal spinel. When A2 plus 2 plus ion means in case of this MgFeCO will occupy the tetrahedral site, and B3 plus means Al or Fe for zinc and cadmium will occupy the octahedral sites. Here you have to calculate the energy by considering the crystal field splitting to know whether it is stable structure or not, normal spinel unstable structure or not. First consider A2 plus ion is occupying the tetrahedral site. So you draw the splitting pattern and calculate the energy. And then to know the inverse spinel, you can further put it in the octahedral site and calculate the energy. Which one is coming lower, that will attend either normal or inverse. Is it clear? For inverse spinel is having the opposite site occupancy. In case of B3 plus, occupy the tetrahedral site, half of B3 plus occupy the tetrahedral site, and half of B3 plus and all A2 plus occupy the octahedral. Only here is the difference. Half of B3 plus occupy the tetrahedral. Okay, and half of B3 including all A plus occupy the octahedral site. This is from the inverse spinel. Okay, so the splitting you have to calculate the energy, and you can see that which one is more stable. If normal spinel is stable, it will form the normal spinel. If inverse spinel is having the lower energy, it will form the inverse spinel. Example of formation of inverse spinel is FeO, Fe2O3, Fe3O4. This is rust. Okay. And Ni, Fe2O4, CO, Fe2O4. Those are the common from the inverse spinel. Is it clear?
Sir, how we will calculate the
You can calculate it from the crystal field splitting. You draw the structure of crystal field splitting, and you can calculate the energy present by putting the electron. Yes?
Yes, sir.
Then for normal spinel, you have to consider A2. All A2 is having this structure. Say number in case of here 1A. So for 1A you calculate this, and for B3 plus, B3 2B is present. So by 2 you have to calculate the octahedral energy and sum up these two energy. You will have a value. Now you go to the inverse spinel. Consider that half B3 means 1 B3 is present in the tetrahedral site. So draw the tetrahedral splitting and place the electron, calculate the energy, and other B you consider the octahedral including A2, it is also octahedral, calculate the energy, sum up these three energy, you will get the value. Which one is lower? You will know that it will have this spinel structure. Am I clear? You have to verify which one is lower
Yes,
value,
sir.
that will have this structure. Okay. So as we have already explained that from the valence bond theory, it is we can predict the magnetic property, whether it is diamagnetic or paramagnetic, but it is difficult to predict quantitatively. Means the number of free electron present, it is not exactly possible to predict by using the valence bond theory. However, it is possible to predict applying crystal field theory. And so using crystal field theory, it is possible to have the value of magnetic moment for the complex compound. Okay. So here means quantitative interpretation of magnetic property of the coordination compound is possible using crystal field theory. Actually, this is the disadvantage of valence bond theory. Okay. Here, in case of coordination compound, it is responsive towards magnet because of the presence of the spinning electrons. Because spinning electron itself is generating a magnetic field, electromagnetic field. Okay, and that is why it is interacting with the magnetic field. When it is not cancelled by the other oppositely rotating electrons. I mean to say that if two electrons is pair up, one is rotating in one direction and other is rotating in opposite direction. So those two is creating the magnetic field, but one is cancel out the other. That is why when it is paired up, the electron is not having any magnetic moment and it will not interact with the external magnetic field. Means it will not show any magnetic property. Am I clear? So
Yes, sir.
here is the formula that how to calculate the, we have to know the unpaired number of unpaired electrons. If we predict the number of unpaired electrons using this formula, the magnetic moment mu s equal to root over n number of unpaired electrons n plus 2. This is the arbitrary formula which we can apply to get the, to predict the actual magnetic moment of the coordination complex by knowing the unpaired electron present, number of unpaired electron present. Okay, and unit used Bohr magneton. Okay, so if we, for coordination complex, here is the figure as I have explained. For coordination complex, this is D7. For D4, this is low spin, high spin. So in case of D4, if we consider low spin, here is lone electron is 2, but for high spin complex, the lone electron is 4. That is why the high spin complex is having high magnetic moment. And you can calculate by putting 2 in this formula, so you will get the particular value. Here in case of D5, only 1 electron is free. Here 5 electrons are free, having very high magnetic moment with respect to the low spin complex. For D6, low spin complex, magnetic moment is 0. Whereas it is having high magnetic moment like the D4 because 4 electrons are free. Okay, so you can verify it by knowing the number of free electron, and it has been observed that when we are running the experiment, experimentally determine the magnetic moment, it is coming very close with the predicted one. So it is a hypothetical formula which is giving very close value of magnetic moment which we are getting from the experimental value for coordination complex. Is it clear? So you can verify the magnetic moment of any of the complex you know. For example, cobalt from 3 octahedral complex MCl42-, they have magnetic moment 0, 1.73 and 3.9. It is not in order. You have to assign which one is having which value. Okay, you can calculate by using the formula and draw the splitting. Then you know the number of electron free. Then you can know which one is having which value. Here answer is first one is having 3.9, second one is having 1.73, and third one is having 1.73, second one is 0. Try to solve this problem. In your room. Okay.
Just 1 second. I just think I missed something in the upper paragraph or paragraph just above this. A bit, yes, sir.
This diagram explains that.
Below.
Sorry. Okay. That I have explained that when electron is paired up in a orbital, then one is cancel out the magnetic moment of other. But when it is lone in the orbital, so it may give a particular magnetic field which may interact with the external magnet. So the compound is having magnetic property. Is it clear?
Yes, sir.
Yes.
So what did you explain after this?
This one. You are asking about this one.
Yes, sir. I guess I am asking about that.
This is the see. This is D4, means the 4 electron present in d orbital for metal ion, and it may form low spin high spin complex.
Yes, sir.
So
Yes, sir.
okay, it is the splitting pattern have shown to calculate the number of free electron. If it is low spin, less number is present, so magnetic moment becomes less.
Yes.
Okay, but still both is paramagnetic. But for 6 it is diamagnetic because all is paired up, having zero value. Is it clear? And other property, as we have already explained, the color properties. Color properties here, important thing is that probably you have played with the color wheel. Do you know color wheel? When we rotate the color wheel with high speed, you will see the white color. But actually it is painted with the Vibgeo color. Have you seen this toy, color wheel toy? Okay. So anyway, actually this is a color wheel where not all the colors of Vibgeo is given, only V, B, G, Y, O, R is given, because V and I is nearby color, and those are not having very intense difference. That is why the color is in this, we may subdivide it into 6 part, and 6 color is given here, not the 7. V, I, B, G, Y, O, R. Only I indigo is mixed up with the V. And here important thing is that the compound absorbing the light, if it is absorbing this region, so we are getting the color of yellow. The question may comes, why we are seeing a red sun as a red color? This is because it is absorbing the light in green region, so we are having the red color. This is known as complementary color. The color absorbed that we are not seeing, the complementary to the color absorbed we are seeing as a actual color. Means red shirt is appeared red because of it is absorbing in green region. Is it clear? So, and it is also well known to you that here is a visible region of light, that is 400 to 800 nanometer wavelength. However, some of the book given the different value, but generally visible color is used. Some of giving 380 to 780. Anyway, it is the average value, so no need to bother about. Okay. So here we will discuss the color property rather in the next class. This is the preliminary introduction I have given, and we will discuss the color property of the coordination complex in the next class. Why those are showing the different color? That we have already explained in that we have already told in very first class, that the coordination compound can show the different color. Okay. So do you have any query? And one thing, probably within one class or two class, maximum two class, I will finish this. So today is Wednesday. Next Wednesday it is holiday. Okay. So you have to attend a quiz on next Monday on this module. Next Monday means
next to next Monday.
yes, next to next Monday means it is on 1st February. Is it clear?
Okay, sir.
Sorry, 31st January. It is 31st January. You have to attend a quiz. It should be short answer type. Short answer type quiz, multiple choice type. Sorry, multiple choice type, 20 question. Multiple choice type, MCQ, 4 option will be given. You have to choose one.
The Google
Okay.
Form or MS Team?
Through MS Team.
Okay.
I will explain you everything before the exam. You prepared for 31st January. Quiz for the first module, 10 marks, 20 MCQ question from the whole module.
Okay. Time allotted?
Sorry?
Time allotted?
Time allotted is 45 minutes and you have to submit within the 50 minutes. Otherwise, computer is maintaining that you will unable to submit and you will score 0. So within 50 minutes, you must have to submit. Time is 45 minutes. Okay.
And the question will be 20.
Question will be 20 question, 10 marks. Half marks is question. Okay.
So why not take 10 questions of 1 mark each?
No, I will decide it because it is 10 question from this big module. It is very difficult to assess. You know,
so the date is
as it is multiple choice type. So for 1 mark for one question, it is not should not be.
So this is not any hard and fast rule that every module will have 20. Every quiz will have 20 questions in 45 minutes, right?
Yes, here is no hard and fast rule. That is why I am informing that I am going to I am going to give 20 questions.
Okay, sir.
So date
is 31st January. 31st on the class time. Okay. Instead of class, there will be quiz. Only this is the difference. Okay. Class time is same. No need to worry about.
okay, sir.
Okay. So if you have any query regarding the quiz, we will answer it in the next class. Okay.
Sir, please upload this module on